A very good morning to all the respected dignitaries and participants present here. Today is the fifth and final day of our online faculty development program titled Recent Advances and Future Trends in AI and NLP, and this is our first session for today. This is Vidisha Beda, Assistant Professor of Computer Science and Technology Department on behalf of Global Institute of Science and Technology, warmly welcoming you all on today's first session of our online FDP organized by the Department of Computer Science and Technology, the NBA Accredited Department in 2022 of Global Institute of Science and Technology, Holdia, affiliated by the University of WBSCT and VENSD and Macau. As a host, I'm feeling really very lucky and fortunate to announce today's speaker, Honorable Dr. M. Tanvir sir, and it gives me immense pleasure to share a very short introduction of his huge achievements in the field of mathematics and computer science, including applied soft computing, neurocomputing, cognitive computation, artificial intelligence, machine learning, neural networks, pattern recognition, and many such more. Let me confess that I can't even touch 1% of his numerous achievements in my short introduction about him. So I'm requesting all the participants to listen very carefully. Dr. M. Tanvir sir is Associate Professor and a Ramanujan Fellow at the discipline of Mathematics of the Indian Institute of Technology, Indore. Prior to that, he worked as a postdoctoral research fellow at the Rolls-Royce at the NTU Corporate Lab of the Nanyang Technological University, Singapore. During 2012 to 2015, he was an assistant professor at the Department of Computer Science and Engineering of the LNM Institute of Information Technology, Jaipur. He received the PhD degree in computer science from the Jawaharlal Nehru University, New Delhi, India. Prior to that, he received the MPhil degree in mathematics from Aligarh Muslim University, Aligarh, India. His research interests include support vector machines, optimization, machine learning, deep learning, applications to Alzheimer's disease and dementias. He has published over 130 referred journal papers of international repute. His publications have over 5,000 citations with H index 35, Google Scholar since November 2023. Recently, he has been listed in the world's top 2% scientists in the study carried out by Stanford University, USA. I repeat, he has been listed in the world's top 2% scientists in the study carried out by Stanford University, USA. He has served on review boards for more than 100 scientific journals and served for scientific committees of various national and international conferences. He is the recipient of the 2023 IIT Indore Best Research Paper Award, 2022 Asia Pacific Neural Network Society Young Researcher Award, 29th ICO NIP 2022 Best Research Paper Award, 2017 ACRB Early Career Research Award in Engineering Sciences, and the only recipient of 2016 DST Ramanujan Fellowship in Mathematical Sciences. He is currently the Associate Editor, IEEE Transactions on Neural Networks and Learning Systems since 2022. Associate Editor, Pattern Recognition, Elsevier since 2021. Action Editor, Neural Networks, Elsevier since 2022. Board of Editors, Engineering Applications of Artificial Intelligence, Elsevier since 2022. Associate Editor, Neurocomputing, Elsevier since 2022. Associate Editor, Cognitive Computation, Springer since 2022. Editorial Board, Applied Soft Computing, Elsevier since 2022. International Journal of Machine Learning and Cybernetics, Springer since 2021. Associate Editor, Frontiers in Applied Mathematics and Statistics, August 2022 since. And Editorial Review Board, Applied Intelligence, Springer since 2020. He is guest editor in special issues of several journals, including ACM Transactions in Multimedia, Applied Soft Computing, Elsevier, IEEE Journal of Biomedical Health and Informatics, IEEE transactions on emerging topics in computational intelligence, multimedia tools and applications, Springer, and Annals of Operations Research, Springer. He has also co-edited one book in Springer on machine intelligence and signal analysis. He has organized many international and national conferences, symposium, workshop as general chair, organizing chair, coordinator, and delivered talks as keynote plenary invited speaker in many international conferences and symposiums. He has organized several special sessions in top-ranked conferences, including WCCI, IJCNN, IEEE SMC, IEEE SSCI, ICO NLP, and many more. Amongst other distinguished international conference chairing roles, he is the general chair for 29th International Conference on Neural Information Processing, that is INI 2022, the world's largest and top technical event in computational intelligence. Dr. N. Tanvir is currently the principal investigator or co-PI of 12 major research projects funded by Government of India, including Department of Science and Technology, that is DST, Science and Engineering Research Board, that is SERB, and Council of Scientific and Industrial Research, that is CSIR, MHRD, SPRC, and ICMR. He is an elected Board of Governors of Asian Pacific Neural Network Society, APNNS, and elected INSA Associate Fellow. So you guys can understand, you all can understand that how much respected person he is and what are his achievements. So I'm very much lucky that I can introduce him with you all. So thank you, sir. And are you there, sir? So over to you.
Yeah. So thank you so much, madam, for the nice and very detailed introduction. Thanks so much, and very good morning to everyone. And first of all, thanks to the organizer, the whole team, especially Dr. Uh, Mahidul Islam, for inviting me for this FDP. So, and giving me a chance to speak in front of the participants of this FDP. So essentially, I thought to discuss various other topics. So, but I thought that it will be more easier and could be very helpful for the participants, because I heard from the organizer that most of them are faculty members in this FDP. So I plan to discuss how to handle the large scale data using SVM and advanced SVM algorithms. So I choose the title large scale SVM algorithms and applications. I'm sure that some of you may have the idea after this talk to in the development of the algorithms and apply these algorithms on several other directions. So I can start with just a brief introduction of support vector machine. I'm sure that many of you are aware about SVM. So support vector machine is one of the most powerful tool for classification and regression problems. It was developed by Wapnick and his co-workers in 1995. And it has been now applied almost in all possible directions, including sciences, all maths, physics, chemistry, and all engineering sciences and healthcare industries. People are using or at least applying these algorithms or advanced SVM algorithms for as a tool for their task. So the basic idea of support vector machine is to find the best hyperplane between positive and negative samples. So if I just start with the very basics that what is the linearly separable problem. That I started that the basic idea of support vector machine is to find the optimal hyperplane, that is the best hyperplane between two classes. So what is the meaning of this optimal hyperplane? So we can discuss this point here. So before moving to that, let me discuss some keywords that we are using. Like consider the training set here T, x1, y1, x2, y2, xl, yl. So here x1, x2, xl, they are essentially the inputs and yi are the corresponding output, that is class plus one or class minus one kind of, right? So if there exists a W vector and B any real number, so and a positive number epsilon, so then W transpose X I plus B greater than or equal to epsilon. And we also have like W transpose X I plus B less than equal to minus epsilon I. So we simply say the training set and the corresponding classification problem is linearly separable. So essentially, support vector machine is find a separating hyperplane, that is W transpose X plus B equal to 0. So between positive class and negative class. So how to do that? So the first property is maximizing the margin concept. So what is the meaning? As I mentioned that we want to find out a best hyperplane between positive and negative samples. So in other words, we can say that we have a separating planes lies between the bounding planes, that is corresponding to class plus one and minus one, and the data points which lie on the planes are called support vectors. Means those red points are called support vectors. They are lying on the supporting hyperplane or bounding planes corresponding to class 1 and class minus 1, plus 1 and minus 1. So if you look at this pictorial representation, so one can see that this distance is essentially as called the margin. So this distance is essentially as 2 upon norm of W. How to calculate is easy. That suppose I want to calculate this W dot X plus B equal to 1 and W dot X plus B equal to 0. So essentially, when very simple formula, we can easily see that this will be 1 upon norm of W. And similarly, 1 upon norm of W is this one. So the total is 2 upon norm of W. So as I mentioned that the idea of support vector machine, that is to find out or maximizing this margin. So maximizing this margin in such a way that the data point should be above this line and below this line, right? So it means that we are maximizing this margin subject to the conditions that the data point should above this and below this. So this is the standard SVM formulation that we can write that maximize 2 upon norm of W subject to the constraint that W dot X plus B greater than or equal to 1 and W dot X plus B less than or equal to minus 1. So this is the original standard SVM formulation in the literature. So, and if there is any misclassification, for example, if the data points of class plus 1 lie in class minus 1, or data point of class minus 1 is lie on another side. So then if there are some data points, so we penalize those data points and then we add in the objective function, and then we use this C is a parameter that control the overfitting issues. For example, if in a classroom boys and girls are sitting, boys are one side and girls are sitting on another side. If one or two boys and girls are mixed, means on wrongly sitting, so we penalize those boys or girls. So we put in the objective function and then minimize, and we just use as a error term. So you can see that we minimize this. So now we started with this one, that we are maximizing this margin, okay, 2 upon norm of W. So essentially maximizing 2 upon norm of W, equivalently we can say that we are minimizing W, right? Or we can say minimizing norm of W by 2, or we can equivalently we can say minimize